We have a problem that looks at aniline chloride, and it wants to know what will happen when it's added to water. So aniline chloride, according to the problem, is C6H5 NH2Cl. All right, aniline chloride. Now, that word, aniline chloride, is kind of helpful because you might be unaware of where this compound splits, but it looks like part of it is something called aniline, which is probably new to you, but the other part is something called chloride, which is not. Therefore, according to the words, this compound must split right there. There's the aniline, and there's the chloride. So it's salt, because that is polyatomic, and this is... rather, it's a polyatomic bonding, therefore we know it is ionic. So I need to find the parents, as always, all right? Therefore, we've got this funky parent, which, look, that's a nitrogenous base, but I know that this parent right here, the HCl, is definitely strong. And I know that this other guy, even if you add the OH to it like you would normally do, that there's no way that it's going to form one of your strong hydroxides, because we know our strong hydroxides are only alkali metals and some of the alkaline earth metals. So this will be the weak side, and now I know what will hydrolysize. So my strong ion, the chlorine, will be a spectator ion. The weak ion is going to be added to water. So let's go C6H5 NH2. All right. So I want to add him to water. Now, this is not a mathematical problem, so I don't have to hydrolysize in a rice table. This is a conceptual problem. So let's take a look at what we know. All right. This item here is definitely not being treated as a, all right, got a phone call coming in. Of course, during my video. Okay. Anyway, so we know that, hey, look who won. Look who won. My acid won, correct? Hey, if the acid wins, what substance must be flourishing over here? That's right, hydronium. All right? It's the only way for my acid, the HCl, to end up being my winner over here is if we have that hydronium floating around. What's the only way to form hydronium? Well, here, it would require an H to be donated from the aniline over to the water. So let's reflect that change. All right, C6H5NH. All right, now no charge, and we're missing a hydrogen. So it said predict the product. So here's the product part of the answer, right? Is that right there? And then the other thing it wants to know is what will the pH be? Okay, well, that's easy. All right, we know the acid won. We know the H3O is flourishing. Therefore, the pH must be less than 7 because a pH less than 7 supports an acidic environment.